How's it going, everyone? Welcome. Elvira Gonzalez here. So, I want to dive deep into the custom hook, the data fetching, and the memorization technique. Because, as I understand now, React and what React is at the end of the day, which is useful for writing UI. And this was something that was developed by the R&D at Facebook, or formerly Facebook, now Meta, where they have this engineering a particular problem to have the same piece of information scattered across different user interface. And if they want to change one piece of information, they need to remember, which our human mind is not good at doing that, especially if you have to deal with these large data sets. Uh, when we need to change and when we need to apply those changes. So, because traditionally we use is the MVC as a way to now write this kind of application in the distributed environments, where now those apps that we write are not any longer living inside of our machine. So they now might live, in some cases, most of the time, live on the other computer, on a server. Why is that? Well, because now it is quite compelling for a lot of these companies to say, hey, I'm going to offer you this service, which is something that, for example, Amazon, Microsoft, and Google has offer, right? So I'm gonna offer you this access to a particularly page, all right? So anytime that you need to run some queries or to get something, particularly when you want to get some data, right? So you want to query some data. Well, I'm going to use my databases, all of them, of course, centralizes, and then provide you the careful, handcrafted, curated results. All right. So this is quite convenient for the companies as well as the users. But one of the trade-off is that users now are seeing are are are, are so users now are only seeing is um um so users now are only sees is what this queries, or what this company wants you to look. All right, they are showing now this. Hmm. Hmm. Okay. Mm-mm-mm. Bounded? I don't think it's bounded. Mm, mm. Anyway, Jesus. So, so now they're that's fine. That's fine. That's fine. All right. So now, so yes, okay. So now all of these companies are showing is this bounded response. All right. Sometimes that this is what you might want to go with. All right. But some others, this is not. It's not enough. So, but for most of the time, most of the use cases, from the user perspective, yes, this is what we want, right? So we sit, or we have now our mobile, and then we tap on that query. So we tap a query that is now is being retrieved by those services that live in one of those data centers Amazon, Microsoft, or Google most of the time, right? And then now they going to provide you the bounded or curated response. Okay, so why this is important? Because as we write applications with React, okay, and the idea of using React is that in theory you have now is a centralized place to store and to manage your data, and anytime that somebody update that piece of data, any other component that have access to is going to be now sync with it. So that's the whole premise of the React uh, in any platform, whether it's on the web, on the mobile, and also on rendering 3D elements on the web, right? The web LG. So I look at, well, okay, so how you can create is your own React, what React is doing behind the scenes that actually is creating is all of these dump nodes. And anytime that you call this function, which is the create element, what is doing that uh, behind the scenes, right? So instead of creating now an element, for example, when you use now document.create elements, what give you now is a, in our case on the web platform, it creates now a HTML tag, a DOM node, particularly an HTML tag. Okay. Uh, so here React say, no. I'm going to create now is this JSON that describes the current state of your UI. And the anatomy is, hey, you have now a ref, you have now a key, you also have the props, which is something that you can pass to this component, as well as the children, so you can render as, so I can pass now dynamic data, so you can render as part of your content, okay? And also some of these methods that React provides us, which is React fragment, for example. So if we don't want to pollute all our components with div, so we can use now this React fragment. And then now doing is the most common things that JavaScript developers or web UI developers we do, which is rendering a list of elements or collecting forms. So there's several things. Or you render a list of elements, or you conditionally rendering elements, or you collect data from a form. So for the first case, I look at how to do that, the convenient way of using now most of these array methods from JavaScript type, JavaScript values, right? And why we always want to generate or provide now a key to the React, and how we can conditionally rendering elements here using is the if statements or the and expressions or the ternary expressions, and how we can now apply is CSS to our React components, right? And the difference between now GSX, which is a way of how we can write now UI elements instead of calling React create elements every time that we need to create an element, okay? And what is the difference with GSX and HTML in GSX and other templated languages? And then also I look at how to collect data from a form. How can we describe a form to collect some data? And here is now when the so handling events is quite important to understand first. So without React, the way how can we do this is by passing a callback to an event listener, or by passing a function call directly to the HTML tag. But React in this case is saying no. I'm going to receive is a function call, and then when I detect that event, that user events, I'm gonna call your function for you, and then I'm going to inject some additional properties so you can now do more useful things here, right? So because of this particular way of now calling our functions for ourselves, and since at the end of the day, React, the core loop is all about to synchronize that piece of information to any component, any UI that use that state, right? This is why I look at the core loop using now the useState, which is something that React provide to say, hey, anytime that you need to store memory or that you need to remember a piece of information over time, uh, this is the function useState, and this works by uh, React provide you is the value and the setter function. So anytime that you need to update a particular or that piece of information, you use a setter function, okay? And when React detect that, it say, all right, who triggers that? React has two scenarios. The first is when the initial render happens, when the initial page load, um, and this is when it's going to create actually all of these elements and append that to the DOM, okay, append.child. But once the component of your app is mounted, now React will gonna detect React will detect is which components trigger that one, and then it's going to now render that component, which is in this context is calling that function, and if that function contains more React elements, it's going to continue to call that, and on every React function call is creating now the JSON to spot the difference between this new snapshot prior or versus the prior snapshot. And with this, now it's going to spot the difference and apply the necessary DOM updates on the commit phase to the DOM. So the browser now detects those changes, and it will run or it will paint that to match the UI with your React state. So all of this is part of the core loop, and it's important to understand because this is what, at the end of the day, the value proposition of React. All right, and as of JavaScript developers, we also need to write forms and collect data out of this. I look at how to do that using now a form, the legend, in especially when you need to grab some data from a input, whether it's the input text or password or email, so you can grab that data, and when you now attach is the value and the setter functions to that input. This is known as control input. So now React is controlling when that input change, right? Sometimes this is not, this is, you don't want this, all right? uh, Sometimes you do, but and when you decide this is depend of how long is your form, right? So for onboarding process, sometimes if you want to split that onboarding process to collect data in several steps, this might be a good candidate uh, to go with, right? Or if you have to show a huge form in one page, you like to go with the uh, form API, right? Instead of directly binding that. Again, it's going to depend of the size of your form. But in any case, so for small forms like inputs and a password, most of the time I will go with input control. But if you have a huge form, I would prefer to go uh, with the form API, right? Why is that? Because anytime that now a state change in that input, right? So when React detect now a state change, it will now trigger a render, aka it will now have to evaluate that functions. So this might not be a huge deal, all right? But if you have a form nested in other components, all right, or if you have a form that live inside of some SaaS applications, this might be quite problematic. But in any case, so here I look at how to do that, right? And the different, on the most common inputs, whether I type text, email, or password, all right, and other like select or radio buttons or checkboxes, right? And then these last two scenarios, how important is for us to look at these the property like ID, name, value, and check. Why is this? Because these specific inputs, like checkboxes or radio buttons, are actually quite we use this all along to in our UIs, right? So when you want to create now, for example, in radar buttons, hey, which one of these, for example, countries you want to go with, and the other is, all right, so which one of those options, let's say you are now selecting is several pizza toppings, all right, you want to add to your order. So it is a particular way of how to handle that. But in any case, from all of those inputs, you want to is you want to do that in a unique pattern or a unified pattern. This is why now React with all of these inputs is quite convenient to go with and use the value and the unchanged property. So after I went through that and understand how you can create your own forms, right? And the different forms and inputs type, whether it's range or the checkbox or the radio buttons in the input type text, email, and password. Select. Then I also look at how can we now dynamically assign unique values to when we rendering a list of elements. Why this is important? In the case of React, because it's generating now all of these elements, so React need to keep track of those elements. So that's why we pass now, for example, that's why we can generate dynamic elements here. Whether it's using is the master random or the crypto get random UUID, all right? So, and because now the state depend where you put in your components, at which part of your render tree live, is going to detect and it's going to define when this it's going to define the rendering process. It's going to define is when this component will update it. Let me put it here. Sorry. Okay. So whatever you define whatever you define your state in your app, that will impact of when that component gets triggered and how many elements it will affect. All right. So why this is important? This is a process known as lifting the state up to choose where you want to this state live, because it will impact all the subsequent DOM trees or React nodes, right? So sometimes you want that piece of information to live further down the tree, all right? And sometimes you want that to live at the top of your component. Why is that? Because, for example, if you're building now a landing page or a blog application, so sometimes you don't require some global state, right? piece of information that you want to access globally. No, you don't need that, right? You can also is rely in some cases on the local store, and that's it. But other times you do need to actually keep track of several elements here. For example, heavy clients applications like some games, all right? So now you define, sorry, your state, all right, uh, at the top of your component. Here is when we use now, for example, Redux, which is an state management library. But sometimes now that piece of information now live outside of our applications in a server or in a database, and then we need to synchronize with that. So for example, when you're building some SaaS applications or back office, okay, now you have a different set of problems. First, you need to fetch the right data at the right time. You need to somehow revalidate that data so you don't get stale data, and you need to catch that response so you don't want to hammer in your API, uh, and you also want sometimes is to predict what this request will be. All right, some UI optimistic, as React call, and the other is pagination. Okay, so because now this set of problems enter into network issues, right? So you have now a different particular tool that do that for us. So whether you go with Next.js or SWC, stale while revalidate library, or Apollo client, or or Apollo client, or the React query, all right? Each one of those tools solve this specific problems when your writing is now SaaS application or back office applications. So why this is important to know? Because as you write more and as you write more application, you started to understand what we are building here. This makes a lot of sense of which tool you want to go for the job, right? So, so now that we look at that, and in here in this model 3, is describing that because now we have components, we now tends to overuse that because that's the only tool that we have. So it's like you have now a hammer, and then you go around your house and hammering things. So not only hammer a nail, but also you use the hammer to eat spaghettis and try to unclog your toilet with the hammer, you know, because that's the only tool that we have in our case component. So the React team say, sometimes we don't want to, so sometimes we want to is just rendering or just running is some business logic here. And because component was the only tool available, that's why we have now that all over the place. So the React team say, all right, so let's go, let's show us, let's show here this tool known as hook. So hooks now allow us to first hook into specific React tools or tasks that are frequently when you're writing this kind of applications, okay? And the other is when you want to encapsulate your own business logic, your own React business logic. So the most common hooks are, for example, use ID. And here is anytime that you need to have some, to let React to have a global identifiers, we use this. When can we use this? For example, with forms, all right? When you want to attach now a particular ID label, HTML form, to an input, all right? So you have now unique identifiers for all of these inputs across your applications, which is something that you want, right? So you want uniquely identify is the label and the input. That's the main cases. That's the main case. And anytime that you use now your hooks, uh, the React hooks, it comes with rules. First, always put your hooks at the top of your components, uh, and don't put hooks in loops, in any looping syntax, or a conditional statement. All right. Uh, and that go beyond the scope of today's video, but that's quite interesting and why that works in that way. And also is the use ref. So anytime that you need to store some piece of information over time, all right, but this time this won't trigger a render. So you can hold now is objects, arrays, or any JavaScript value type. But most of the time here we use this to hold now DOM elements with useRef. And I look at what is the most common things to do with. So for example is, hey, I do want to focus an element here. Or I want to grab now an element and then interact with it. For example, a video or an audio, right? Or even a canvas, all right? And another hook is known as the use effect. So anytime that I mentioned before that you need your piece of your React application to synchronize with another source of truth, all right? Or anytime that your React app needs to synchronize with an external source of truth, let's say a database, or reading the local, or writing or reading the local storage, or um, synchronizing with global events, or even do that with timers. So for this specific case, now React say, all right, so I'm going to provide you this effect that I'm going to run after every renders. And here's how these things work, right? You pass now a function to this effect, all right? Inside of that function, you define your logic, all right? If you don't pass now any, this is the first parameter, and it's the second parameter. If you don't pass any, if you don't give me anything, I'm going to run this effect after every render, right? But if you do instead pass now as a second parameter an empty array, I'm going to run this only once, okay? But if you, for example, you need to synchronize is with stale, or if you need to if you need to run this effect, this JavaScript function, when one of these state change as a React as a dependency, as an array of dependencies, right? Well, we do need to is pass that to the array as a second parameter, as an array. So okay, so I look at most common use case. So for example, like, hey, I do want to now synchronize this state in React to, for example, my document.title, all right? Or I want to now is synchronize is with the some global events, for example, like mouse move, or resize, or even the interception observer. Okay, so that's great because these hooks, right? It also have some rules. So the effects linked rules, where any time that you want to suppress that, I mean that'll work, but you are now setting yourself for into trouble. The TLDR is that there is a reason why you, some cases you need to define is the array of dependency. And if you don't want to do that, we can use now is the, so setting the state by passing is a callback. So you can get the fresh state anytime that you run that setter function. This can be quite confusing because there is a lot of works involved. Uh, I also going to write an article later uh, describing that kind of stuff. But the TLDR is that once you know how this effect runs and what you can do inside of your effect, right? Then, well, sometimes you want to these components to desynchronize or yeah, to desynchronize for that external source. And then resynchronize when this component is mounted. This is known as the cleanup function. And here, because with effect we pass now a callback function that describe what is the thing that we want to run after every render or after one of those dependency change, right? On the cleanup function, which is when we return a function, here we want to define is the unsubscription logic here. So in the case of our window mouse move or resize, we want to remove that event listener to that. So now the browser doesn't need to keep track of that. It's like, hey, freeze memory for this, okay? The other is for reading their local storage as well. I also look at how we can or unsubscribe from the for example on the mouse move or resize global events or the interception observer, okay? And another thing that when you are using the array of dependency is that sometimes you do need to get is a fresh state of that, but you don't know when that state is fresh. So this is why I use is now these callback functions to say, all right, now here I want to get the freshest state and use that to synchronize my internal state with this piece of information that I'm receiving from an external system, right? Why this is important? That's a great call. For example, state values or stale values here, right? Focus and iframe. Let me read about this for a moment. If you like, I have encouraged you to spend a couple minutes attending this problem, but I will warn you, it is surprisingly tricky. Focus and iframe. The playground in the okay, this is just describing what sometimes is quite tricky. To test your solution, you will need to click within the iframe so that the space bar events trigger within the right context. Exactly. You can click anywhere within the iframe. So here, when I click now here, and it's interesting because it reacts to keyword inputs. Again, I am subscribing to this key on input, all right, or key down global events, and because how the events works in the browser is by whoever components triggers that, or whoever target triggers that. So first it's going to look down to the element that triggers that, right? Which is the target. And in our case, when we click here, it's actually focused on that, and that's the target. And when it detects a particular event, in our case, the key down, and if that match to the space code, all right, then it's going to now run this callback function for itself, right? So that callback function is interesting because uh, we are now passing is a reference here. We're passing is this function's reference, and because of this, right? Whether if we passing now here as an array of dependency to say, hey, is playing, because we can actually say this is play and say, hey, let's gonna do this, right? I want to flip now is playing, right? So here we're passing is now to reference, okay? So here, when we're trying to run this code, okay, it actually works as expected. There is no problem in there. And even we add this unended, right? But why this is important? Well, we can even remove this. Exactly. Why this is important? Well, because this show us is how now is the react or the effect life cycle. So when our component mounted, in our case here, right? So when these components mounted, it will now run or will kick out this function, all right? And here, since we are now is starting is a long running process, right? This synchronization is important to understand because we are kicking off this one. We need to, when this component is mounted, to remove that long running process. This is why we did subscribe to this, okay? But when this is triggered, well, it turns out that when this is part of the component's life cycle. So when the component is mounted, it's going to render the component and then kick off the effect. And in our case, we are now running this long running process. So on any time that these components change, or particularly the state change, all right, it will now is call the cleanup function, and then, which is now the register, and now it's going to register the key down process again, right? This might be quite negligible for these cases, but you can see that this process of desynchronizing and synchronizing and so on and so forth, anytime that a piece of information change, is something that, again, for this particular exercise, is quite negligent. But if you can think in a scenario when you want is just to run a long running process, rather than flipping from one to another, right? Rather than toggle that process on and on and on and on and on and on, right? So if this is if you don't pass any dependency, right? You now have this. If you're adding a dependency, what you're doing is now triggering is this synchronizations process over and over and over and over. However, if you only pass now a callback function, you are now setting is a long running process, right? That's very, very interesting. You're running into a long running process here. Again, sometimes this is what you might want, all right? And starting this long running process, what it's going to do is anytime that you need to read the data from it, or to get the fresh state value, it's going to get that from the components instance and update that accordingly, right? So why this is important? That's the whole point of this. So why understanding how now the effects work in these three scenarios without dependencies, all right, which is now running this, without dependencies, which now gonna get triggered is on every render, okay. And again, it's starting this long running process. If you now setting out an array of dependencies, and if you're synchronizing with an external system, what you're doing is now flipping from from synchronized to desynchronization, and so on and so forth. But if you want to use now a callback function, you just now starting off a long running process and get the fresh, and if you want to update that state, you can do that, but by pulling the data from the components instance. So I know that this might sound quite hard to grasp on, but I understand anytime that you need to use the effect to synchronize with an external system, which is why this thing exists, all right, is to ask yourself, how often do I need to synchronize and desynchronize with this system, right? So for example is, you can think in a scenario when you want to avoid this kind of switching, especially using webhook, or for a chat application. You don't want to do that. You just want to start a long running process, right? And when that component is mounted, okay, let's get rid of that, right? So again, this is quite useful to now understand these state values that are being created, and when you want to synchronize, and for how long you want to synchronize with that external system, right? And how useful is for us to use the state setter callback to get the fresh state out of that and work with that, right? So for example, like this. Most of the, and this is exactly, and this, most of the time, we don't need to use the callback system. The main use case for the syntax, in my opinion, is to avoid the stale values. Issues we saw in previous lesson. Stale values aren't strictly a use effect thing. We can also run into this sort of issues when using MIMO or use callback, discussed later in this model, and also when doing asynchronous work, fetching data, discussed in the next model. So occasionally it can be more convenient to use the callback syntax, for example. So you can run into these stale scenarios anytime that React need to, or when you need to keep track of these dependencies, all right? You can run into these scenarios. Occasionally, it can be more convenient to use a callback syntax. For example, if we're passing the state setter function as a props to a child component, we can use the callback syntax to modify the current value without also having to pass the value through props, okay? So for example, like this. This is a typical counter app, and there are no effects, no asynchronous code, and there's no way for the state to grow stale. But anytime that you need to synchronize with an external system or run in an effect, there is a risk for your stale. There is a risk for stale states. There is a risk for stale. There's a risk for stale state. Okay. So if you find yourself in the need to use the fresh version of that state, we use now the callback here. So I also look is now a more or an additional exercise here. So for example, is interval counter. So hey, you want us to now run this, right, and increment that uh, after every second. So because uh, in order to run this timer, you need to run is now a function that's gonna cause this effect, that's gonna give you now some stale values. So by using now an effect and first describe the effect that is going to synchronize with this external system, and in our case is the interval, okay, uh, that of course live globally in our application. This interval, when 1 second has passed, I do want to now set this state out of this, right? So instead of having to resynchronize here, so instead of having to do something like this and call this, which there is nothing wrong with it, right? Count plus one, right? Which there is nothing wrong with this approach. But what it's doing here is that any time that, so here we are, right? First time is going to evaluate, it's gonna say, hey, I'm going to create now a user state that I want to remember across over time. So I want to create now a piece of information that I want to remember over time, and that it will now render this markdown and put the proper value at that moment. And once that is done, it's going to run this effect, would say, hey, let me now is use the interval web API, and after 1 second has passed, set the value of our React state and add that a 1, right? And because now this actually trigger and state updates, right? It's going to now again run these functions, update the proper markdown with that value here, and then run the window here or run the cleanup functions, which is clear the interval. So whatever timer you have at that moment, I want to get rid of that. So free up memory, okay, and then run this process again. And this is something that is going to repeat every time that this piece of information runs. There is nothing wrong with that. But again, you have now this effects kicking off every time that that state change. So an alternative to say, hey, instead of doing that, right, I just want to use is the fresh versions that React gave it to me by setting this function and say something like this. I prefer to call this the current value, current count, right? Something like this. And what this thing is doing is say, hey, I'm going to kick off this effect only once. So I'm starting as this long running process, okay? And when this component is unmounted is when the cleanup function will execute. So why this is useful? Again, anytime that you need to synchronize that piece of state with an external system, and that you want to run is a long running process, using now this code is one way of how you can achieve that, right? So finally, and then right now talking here of the React 19 features, which is now in a strict mode, and here it comes with an additional features, and one of the most or the one that impact developers is the strict mode, which say is like, I'm going to now run your effect twice. Why? Because so React wants to know that if you're using them properly, if you're now syncing and desynchronized from these external systems, right? So that's why revealing. Also, you need to add that strict mode here into your application. So far so good. All right. And yeah, you see how now the effect is running twice. Again, this is exclusively for development. So exactly, this is on a strict mode, and this is on a strict mode simulated.
So as we've seen, strict mode will automatically rerun our effects, right? It runs the effect, then it runs the cleanup, and then it reruns the effect. And this can have the effect of breaking things like our keyboard shortcut if we've neglected to do the appropriate cleanup work. As I was working on this lesson, a question popped into my head. Is it possible to simulate strict mode, or at least this one aspect of strict mode, by rendering in normal mode, but then unmounting and remounting the component? When I do this, it seems to do the same thing, where we see the order of operations is the same. I run the effect, I run the cleanup, I rerun the effect. And yet, when I do it this way, by trying to simulate strict mode, the keyboard shortcut actually works just fine. So there's clearly something different between these two approaches, but I'll be honest, I did not know what it was. Like, as I was working on this lesson, I really had to stop and scratch my head, and I couldn't figure it out. I had to reach out to a member of the React core team who was kind enough to explain it to me. And the difference between these two things is that in this mode, we are removing and then recreating the component instance, whereas with strict mode, it isn't actually destroying and regenerating the component instance. Instead, it literally calls the functions again without touching anything else with the component. I have some illustrations that will hopefully make this make a little bit more sense. They are different from the illustrations we've seen before, right? Before we were talking about like snapshots over time. In this case, we're talking about component instances. And with strict mode, when we mount the component, we generate the instance, we call the effect function, then we call the cleanup function if one has been provided, and then we call the effect function again. And the result of this, in the case we've been talking about, is that we have two event listeners, and they're both toggling the same piece of state on the same component instance. When we try to simulate it, though, we have to unmount and then remount the component. And when we do that, we create a fresh instance. And so we still run the effect twice, and we still wind up with two long-running event listeners, but they're toggling the state on different instances. In essence, this event listener doesn't really do anything anymore because it's toggling the state on a component that's been unmounted. And that's why everything still works, because only one event listener is actually toggling the relevant state variable on the relevant instance. Another way to explain this is, let's imagine the page loads and I toggle the component away. So we've run our cleanup function, we have unmounted the component. None of this JSX exists in the DOM anymore, right?
Exactly.
All of the DOM nodes that were associated with this, like the H2 and the paragraph, and critically the audio tag, none of them exist anymore. We've unmounted the component, we've destroyed all of this stuff. Now, because we're still referencing the setIsPlaying method on the component instance, it isn't truly destroyed, like the garbage collector cannot come along and sweep it up, but it's essentially been neutralized, where it has no DOM to play with, and also this effect that would normally trigger the playing or pausing on that DOM node, well, this doesn't run because the component instance isn't active. And so if I hit the spacebar key now, nothing happens, even though this function is still being fired because I still have this event listener, but it's toggling a state variable that no longer controls anything. And so then, when I'm toggling a state variable that no longer controls anything. And so then, when I remount the component, yes, I register another event listener, but they're both referencing different instances. I have this brand new instance now. And so when I hit the spacebar key, only one of those event listeners is toggling the relevant state. I do realize this is hard to follow, right? This is something that I just learned despite using React for years and years. So it's totally okay if this still feels fuzzy or hard to follow, but I did want to mention this because I imagine some of you may have been wondering the exact same thing, and I wanted to provide an answer.
Okay, but this is while strict mode is technically an optional opt-in mode, is quickly becoming is part of that. Is part of that. Simulating a strict mode. I was developing this lesson and a thought occurred to me. It is possible to simulate this strict mode quirk by unmounting and remounting the component. So here's an illustration. Strict mode. You get the instance one, and then you strict mode simulator. Again, why this is useful? Why this is important? The TLDR is that with the strict mode, now your effects are running twice to check if you are using them properly. That's all. Right? So far, so good. And the other is now with the custom hooks, right? So custom hooks at the end of the day is just a way to bundle. This is the two advantage. So we can bundle is React logic, which in essence, we can bundle is React logic in a functions that we can now put it in a file and reuse across our app, which is great. And the other is that those custom hooks are now ways to describe behavior in our application, which is powerful. Which is powerful, right? So there's some conventions to use a custom hook, like use and the name of that custom hook. Some couple exercise here, so quite convenient. And why this is important to always understand these hooks, right, and use them as it is instead of. I mean, there's nothing wrong with you to use any of these useState hooks or any of these custom hooks provided by a library. But if you do this too often, you're starting to atrophy that muscle because you don't understand what this hook is doing. And that's the interesting part of all of this, right? So for example, here on the mouse position, so what I did is just to say, hey, in this effect, I want to now is listen for these global events, and I'm going to pass a callback that I'm going to read this event that once the browser calls that, this is the function that is gonna call, and this is the parameter of the event. And then I would do want to update those values with my own state in my application, which is this, right? And when this component is unmounted, I want to desynchronize or remove the event listener for that. This is also true for a couple custom hooks, like uses on a screen, for example, all right? And they use toggle here, which is quite interesting. You know, you just change that to toggle clock, and you get that thing. I think that he mentioned something interesting.
So in 2019, I started a new role at DigitalOcean as a senior front-end developer. And I was joining the team at a really interesting time. This was late 2019, so it was a few months after the React team had unveiled hooks, and there was a lot of buzz and excitement and a little bit of trepidation about it. And I was joining the company right as they were starting to migrate a legacy Ember application to use React. And so because I was joining the team with a little bit more React experience than most of the other developers, I sort of saw my role as being like part educator and part evangelist, trying to convince the team that hooks were exciting and good and would help us. And I'll be honest, it was a bit of a tough crowd at times. Like, especially as a lot of Ember developers, they were comfortable with Ember. They sort of understood React with classes, and hooks were just, they were such a departure from what they were used to that they were skeptical about it. And so I tried lots of different approaches, like I showed them different things. And interestingly enough, the use toggle example that we're talking about in this exercise was one of the things that I saw trigger like light bulb moments in the team. Like I could see as I was explaining it, people started to see, oh, this is actually really interesting. Like we can bundle our own business logic, and they started to be able to see how they could use that in their own application. It's kind of funny because this is kind of a silly example. And, you know, I don't expect light bulbs to be appearing above your head as you go through it. But I do think this is a good example of the power of hooks and the ability to create our own abstractions. So let's talk about how to do it. I'm going to start by fleshing out this use toggle hook, and then we'll update app to use it. And I'm going to start by creating a state hook, because I know in React, whenever anything changes in the UI, it's because somewhere a state variable changed. And I could name this state variable showClock, just like I did inside app.js, but I want this hook to be generic and to be useful in many different situations. So I'm going to pick a generic name like value. And I also know that I want to return an array, because the shape of this use toggle hook should look like the shape of useState. So I know that I want to return the value as the first item, and then a toggle function. So I'm going to name it toggle value. And we'll define that function just above, function toggle value. It's going to call set value and pass not value as the argument. So it flips from true to false.
Exactly. So it flips from true to false here, right?
Or from false to true. I'm not quite done. There's a couple little bits of polish I want to do, but this is good enough for now. We can start using it in app.js. So I'll change react.useState to use toggle. I'll change the name of my setter function from setShowClock to toggle clock. And then I'll call this function down when we click on the button. With that done, the clock can indeed be toggled off and on again, right? We have essentially replicated the functionality, but there's a couple things about this that are interesting. For one thing, I'm able to pass whatever nonsense I want into this function, and it has absolutely no effect, right? I'm not actually using the argument. I'm not even taking it as a parameter. So it has no effect. And this is good because it reduces like the amount of places for developer error. Like we can no longer accidentally pass a wrong value because it's not even using that value. So anytime we can reduce the space for errors to slip in is always a good thing. I can also, and this is relatively a minor thing, but because I'm not calling it with any arguments, I can pass the function directly to onClick. I know that this can still kind of hurt your brain a little bit if you're not used to thinking of functions as things you can pass around, but I do think it tidies it up a little bit. And overall, it's just like a nice little abstraction that makes things just a little bit brighter. Going back to use toggle, there's two things I want to change. The first is I want to be able to supply...
Exactly. I do need this to... I want the ability to supply a parameter.
An initial value. So I'll put initial value, and I'm going to pick false as a default value so that even if we don't pass it, it doesn't start life as undefined. It'll always be a Boolean value, and I'll pass that in to the useState call. Now I realize it's also possible for them to pass some sort of nonsense in over here. So let's also put a little bit of a guard against that. Granted, if you're using TypeScript, you don't have to worry about this because you can declare this as a Boolean value. But in JavaScript, I would check the type of initial value. And if it's anything other than Boolean, well, we have a couple options. If we wanted to be really aggressive, we could throw an error, right? Invalid type for use toggle. And notice now, right, I see that error right away because I am indeed calling it with a number. And so if I pass undefined, it works fine because that starts life as false with that default value. I can pass true or false, and we see that that does indeed change whether the clock is shown by default. But I think like this is pretty aggressive. I would probably do like a console warn to at least let the developer know in the console that this is happening. And the last little thing that I want to do is I want to update this setter function over here to use the callback form. And the reason for that is that...
Okay. So, Okay, I can imagine a scenario where I do need is to have access to the fresh state values. Okay.
I don't know, because this is a generic hook, exactly where it's going to be called. I can imagine some situations in which we call this function from within an interval that started when the component mounts and doesn't have access to the freshest value of this state variable. And so even though it's not really a problem in this particular case with the clock, because we're building a generic hook, I want to make sure to safeguard it against as many possible use cases as I can.
Mm-hmm. Exactly. We also need to support SD. If none of them is a boolean and a function, you say, hey, invalid type to use toggle here. And as it is. So you can pass now this as initial value. So again, this is how you can actually see that by abstracting this particular piece of logic here, using is React logic to describe is app behavior, this is when the things becomes useful here, right? And those behaviors, like here on the data fetching, okay, let me see, okay. And those behaviors like data fetching here is why now this particularly custom hooks or this additional hooks, this additional tool in our toolbox is useful. So data fetching. So data fetching is a critical component for most web applications. When we really think about it, most web application exists to let user interact with data in a database. That's all. That's all. Anytime you go to Google or ChatGPT or any or Anthropic, Facebook, TikTok, don't consume TikTok, bro. That's all. It's gonna fry up your mind. Anyway, but anytime that you go to this website or this document, essentially the user what is doing is to interact with that, and so interact with the data in the database. Okay, so search engines are huge databases that let you filter their billions of entries to find their most suitable results. Chat applications like Slack let us send and receive messages stored into their database or in a database. The same for social network, which provide feeds pulled from their database and let us interact with them by updating data in a database. So in the lesson that follows, we'll see how to send network requests in React context. Tool of choice. So there is a huge universal tool out there to manage network requests for us. In this course, we're going to use fetch to make requests, and fetch is a part of the web platform built right into the browser. And luckily thanks for the developers and the spec that actually say, hey, you know what, we need to have a built-in feature to fetch data. Before this, we have this XML so we run this using XML HTTPS, so XML HTTPS or HTTP requests, right? Which provides now a user agent whose methods transfer data between a user agent and a web server. So this is the old way can be used with non-HTTP protocols or non-XML data. But again, this is a way that enables us is to transfer data between a user agent, this application, the browser application, and a web server. Okay. So despite its name suggesting XML only functionality, HXHR can handle any data form, including JSON, HTML, Blink data, and a binary data. Why is this? Because at the end of the day, this is a method that allows to transfer data between this user agent, this browser, and a web server, right? Um, XSR is secure when used over HTTPS. Cross-origin requests require core support from the server, widely supported across browsers since 2015. Oh, this is modern fetch. Exactly. While fetch API is not preferred for new projects due to its cleaner syntax and promise-based handling, HSR remains relevant for supporting other browsers needing fine-grained control over requests, monitoring upload, download progress, and legacy code bases, which is one of the things that Fetch API doesn't provide. That, and that to me is quite interesting. Fetch, um, again, because X XML HTTP requests is for transfer data. And then you got this spec here. Okay. And then you got this spec here. The living standard here. Holy hell, this was updated. Mm-hmm. Mm-hmm. Interface progress event. Mm-hmm. 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 So if I now look at the fetch API living standard, which is a promise base. Mm-hmm. Mm-hmm. Holy hell, that was updated like holy fuck. Um 7 days ago. No, 8 days ago. Yeah, 8 days ago. Holy moly. Fuck. Alright. HTTP extension with cookies. Exactly. Origin header, course protocols, content length, content X type, fetching, main fetch, override fetch, scheme fetch, HTTP redirect fetch, network or cache fetch, HTTP network fetch, course preflight fetch, course preflight catch, course check, DAO, check, defer fetching, and the fetch API, headers, body init union, body mixins, request class, response class, fetch methods, garbage collector, data URLs, background reading, HTTP headers, atomic HTTP, basic safe course, WebSocket, using fetching other standards. Mm-hmm. And the intellectual properties. Mm-hmm. Interesting. Interesting. So it is possible to use mm-hmm. It is possible to use okay. It is possible to use fetch. Oh, okay. Now you don't get it. Mm-hmm. Mm. Fetch with streams API. Get the total size, retrieve the content let header from the response, and use a custom headers like X file size configured on the server, and read chunks Use response.body.getReader to get the reader from a string and track progress. In a loop, read chunks and accumulate the byte length of each chunk. Accumulate the percentage total here. Exactly. Accumulate the percentage total here. Exactly. And you're going to now see that loaded value. This method works for download progress. XML HTTP request. It's because this is a This is a tool for data fetching or for transfer data. Exactly. Data transfer. When you listen to this event, it's going to tell you that less computable percentage. That's a very interesting. Yes, HTML can show require modern browser support and proper server content header. That's a very interesting thing, bro. That's a very interesting thing here. And that's a subtle difference between the fetch, like a bone, fetch and XML HTTP requests. And I think they're using now Apollo for that because it's data transfer. This is for data transfer. In this course, we're going to use Fetch to make requests. Fetch is part of the Web API web platform, but building right into the browser. If you're not familiar, you can learn about the basics of working with Fetch and the Fetch Basic primer lesson. It is becoming increasingly popular in React community to use third-party tools like React Query or SWSIR to help with network requests. In the lesson that follow, we'll see how SWR can augment or fetch requests. Prerequisites. This lesson will focus on how to use fetch in the React context. There is a fair amount of assuming knowledge like synchronous and asynchronous call, promise, async and await, HTTP method, and fetch basics. When it mentions fetch basics, is that how it's retrieving data, and the request options, query and body parameters. Exactly. You need to stringify that query, that body, in order to send data. Similar for the HTTP methods. All right. In the test API that is gonna use here in this example. So fetching on event. All right.
So we're building a contact form, and I've already done some of the work in terms of managing the state. So I have these two state variables, and they're each controlling their respective form input. But when I submit the form, we see a full page reload, not really what we want to be doing, right? The default behavior for forms is to make a request to the current page, whereas we want to direct that request to a specific API endpoint. So I'm going to start by adding an onSubmit handler and assigning a handle submit function. And we'll define that function right above. It'll receive the event. And the first thing I'm going to do is call event.prevent default. This will stop that default behavior where the form submits to itself. But it does mean that I've essentially broken my form, because now nothing actually happens when I submit it. Well,
why is that? Why is that? Well, because when you call the function, you say, hey, prevent the default behavior. And not only that, is that so React is calling that function for us, right? And we are not updating any state here, right? So this event is not updating any state, so it stayed the same.
Let's do something about that using the fetch method. And I've provided the endpoint that we're going to use with my test API, so I'll make a fetch request to that. I have to supply a couple more pieces of information, including the HTTP method, which is supposed to be post. That's the method I chose for this endpoint, which I think makes sense because we're creating a new thing. In this case, the thing is a message. And I also need to supply the data itself, so the customer or the user's email address and the message that they're sending. So I'll pass along email and message. Now there is a very common gotcha here, which is you're not actually allowed to send objects over the network, right? It has to be a string. You can't send arrays or objects or functions. It's just not something that the network supports. And if we don't do anything at all, the browser is going to try and stringify this object, but it doesn't do a very good job. And you've maybe seen this before. Like if I have an object which is equal to, let's say, high5, if I call o.toString, I get a very unhelpful string of object.
Okay. This is when it comes to the type coercion here. Okay, so when I'm trying to convert this into a string, it's gonna have is this, because again, converting from one value to another, especially on an object, into a string, this is what you get. It's like, hey, this is now the objects.
Whereas if I use json.stringify,
exactly, which is the method that is supposed to use, now it's going to take that that value, that object value, and transform into a string.
I get a much nicer string representation of that object, and then the backend can essentially parse this string back into an object. So I'm going to say json.stringify and pass it this object. Now when I run this code, it makes the request. Fetch is promise-based, which means if I want to do something with the request, I'd have to write .then, get the response, turn it into JSON, and then another .then to get the actual. I don't want to do any of that. So instead, I'm going to use the async await keywords. So I'm going to make this an async function, and I'm going to await the result of this fetch and capture it in a response variable.
Or holding into a response variable here.
And to get the actual body of the response, I'm going to say response.json, and I also have to await this, which always, I think it catches everybody off guard that if I've already waited for the network request to finish and I have the response, why do I have to await this? And the short answer is that we don't necessarily know that we have the raw content yet. It could be streaming, for example, in which case it comes over multiple parts. Not the case in this case, but we need to structure our code in a way that can accept any case, and so this is the way to do it. If I then log this JSON, we can see what we get back from the server. I submit the form. If I go check the console, hey, look at that. I see an object. I have an OK property, which is set to true. And then I see that it's reflecting the data that I sent, so I can confirm that it received the data I wanted it to receive. And so all of this looks good, right? We see that the network request is succeeding, but it's not really the best user experience. Like, I submit the form, and maybe it worked.
Nothing happened.
We really have no idea, unless we expect users to go digging into the developer tools, which is obviously an unreasonable expectation. So even though we have successfully completed the network request, our work is really just beginning, and we're going to tackle that in the next part of this lesson.
All right. Exactly. It's just to describe this response, which is somehow, so this is a lot of the gotchas that you get that, right? The browser is trying to transform into a string, which is not useful, all right? And then you get, okay, loading success and error status here. I'm going to leave that as it is, all right? So that'll be all for this video. Take care. Bye-bye.